Welcome back, ladies and gentlemen. This is our third video for looking at some review problems for Unit 3 in Statistics here at Kellogg Community College. I am Mark Anderson, and here we go. For this problem here, we are looking at comparing some ACT scores done in the state of Ohio. And can we conclude that the Ohio's average is different than the national average? And here we have some data here to say that we have the average for the nation, and we're going to compare that versus Ohio. So our null hypothesis is going to be, are the two averages the same? So is mu1 equal to mu2? Or is there a difference? Because it's asking is like, can we conclude that Ohio is different? And so our alternative is mu1 is not equal to mu2. This is going to be a two-tailed test, and since our students surveyed is well over 30, we're going to use the Z chart for this, and our criteria would be if Z was greater than or equal to 30. Well, this clearly breaks that. Now what we're going to do here is look at the critical value. Now we have an alpha of 0.05, and that means since we now have a two-tailed test, we are going to look at the alpha divided by 2, which is 0.025. And with that in mind, we have to look up on our chart, our Z chart, the percentage of we need to find the Z score that's closest to 2.5%, and also the Z score that's closest to 97.5%. Now, you actually have a little bit of a tie on some of your charts there, because you could either pick 1.96 or 1.95, and we're going to go with 1.96 because it's furthest away from 0. Now please make sure that you have your indicator that this is a plus or minus value, because we're running a two-tailed test, so we have to look not only at both possibilities. And this is incredibly important because the way you subtract your mu's and set this problem up will either give you a positive or negative number. And for this two-tailed test, we want to be absolutely positively sure that we get everything in the right order for this setup. Now I'm going to redraw some of this information here because we just did our part B, and I'm going to kind of push this down a little bit, and part C on the worksheet, which says to run the test and show all work, I will go ahead and do so up here. So let me put a part C. Whoops, turn my pen back on again. So here's part C. Also, as a quick reminder, we found our critical value to be plus or minus 1.96. So our test value here is going to take our 2 mu's, and I'm going to subtract my Ohio from the nation. And what's important about that is when I subtract these two values, minus mu, which is 0, mu sub 1 minus mu sub 2. This is from the actual formula, but this is always going to be 0 here for our problems. We need to now go to our denominator, and we need to be very careful about how we type this in. Now both of these standard deviations are the same, so they're both 3 squared over, now in this case this 20.8 is from the nation, so what we're going to do, and I think, from Ohio, so we're going to make sure that this is 500 in the denominator, and then this here is going to be the this is from the nation here, so I want to make sure I keep these in the same order, and if I do these correctly, I get an answer of negative 3.65, which puts us way beyond our 2 critical values. Now since this is a two-tailed test, I do have to label both my critical values that we have here for this two-tailed test, 1.96. So here I have the shaded zone, and here I have another positive shaded zone. And my negative 3.65 just puts me way over here, negative 3.65. And you can see that sometimes I put my numbers up top, sometimes I put them down below. It really doesn't matter. But what does matter is that this is the critical value in both sides. And then this is my test value where I found my actual data where they were. And they were many standard deviations below the norm, which puts us well below that or well below where our target value was. So what we're going to do, since we're in the critical region, we're going to reject the null hypothesis, and we will reject null hypothesis, ECT, excuse me. Looks like a since symbol there. We will reject the null hypothesis because 3.65 is less than negative 1.96, and I could have flipped that around to make it work as well if I went negative 1.96 is greater than 3.65. And you'll note that in my sentence I didn't actually talk about the right tail at all, because the way I subtracted them, the way I ordered them, just didn't make a difference here. So I want to say, that's the end of the problem. And again, if you've got questions, please let me know. Thank you.